Welcome. So this question says a 2 kilogram mass is located at a position 3i plus 4j plus 2k meters, and a 3 kilogram mass is located at position minus 2i plus 3j minus 2k meters. And then where is the center of mass? So we have a three-dimensional problem now. So let's visualize it schematically. So here's my first vector, and that points from the origin to where this 2 kilogram mass is. And this is 3i plus 4j plus 2k meters. That's its location. This is like a vector pointing from the origin to where that mass is. And then we can have a second vector, and this points from the origin to where this next mass is, which is a 3 kilogram mass. And this is at minus 2i plus 3j minus 2k meters. And if I can kind of show that that's that guy. And then I've actually got a blue as well, so that's that guy. So that's where those two things come from. And what I'm trying to find is the position of the center of mass of this system. So I'm going to imagine I want to find a vector. I want to find that vector, and that is where my center of mass is. It's going to be in between these two guys. It's going to be closer to the 3 than it is to the 2. But I need to find the ijk representation of that vector. And so, well, I need the principle that links these guys together. And it is that my r center of mass, the vector to my center of mass, is equal to the sum of ri mi over the sum of mi. It's each mass times the vector that points to its address added together, divided by all the masses added together. So if I look here, I can write this out longhand and say, well, our center of mass is equal to, and we just go through them one at a time. If I go to here, here's my first vector, and I say, well, this is going to be not 3i, but 2 times that, because it's mi times ri. So it's going to be 6i plus, not 4j, but 2 times 4j, 8j. Not 2k, but 4 times, but 2 times 2k, which is 4k. That's my first one. And then I got to add to that, because that's what that summation sign means. And I got to add my second one. And my second one is, I'm basically looking here and there. So for my second one, I'm going to say not minus 2i, but 3 times that, minus 6i. And then added to not 3j, but 3 times that, 9j. And not minus 2k, but 3 times that, minus 6k. And then now I've got to divide it by the sum of the masses, and the sum of the masses is basically 2 plus 3, which is 5, of course. So the rest is arithmetic, basically. Our center of mass is equal to plus 6 added to minus 6i, which is 0i. And then the next one is plus 8 added to plus 9, which is going to be 17j. And then we have 4k added to minus 6k, which is minus 2 k. But I've got to divide that by 5 because I've got to take into account that. So if I want to write this out, and you know, in many cases that would be fine to leave the answer like that with units. It's going to have meters in there, of course. You cannot forget the units just because you have IJKs in there. So then we have 0i. If you want to go to the next level and write it down as a decimal, it would be 0i. It would be 3.4j. It would be minus 0.4k meters. So this is the vector pointing to the position of the center of mass of this three-dimensional discrete, means separated mass system, a three-dimensional discrete mass system. And let's see if we can find it. 0 plus 3.4 minus 4 is the one at the bottom. Okay. So there we have it. We visualized, we found the relationship or the principle that links what we're talking about. We carefully and steadily laid out our steps to work through it. We'll let the math take care of itself. But we helped ourselves by laying out all the individual steps. We did not forget our units at the end. So there we have it.